Beginner level. Beginners often interact with algebraic systems without their knowledge of the math involved. Algebraic systems are found in the Rubik's Cube, Wordle, Mad Libs, credit cards, apps and programs, financial markets, and many other places. Video games are often based on algebraic systems and is not limited to puzzle games. Though some of these systems are not as rigorous as we've grown to expect from math class, the math is there, just hidden. In order for a program to be created, we need to understand the underlying patterns. If a program exists for the concept, it is most likely that it can be described using mathematical tools. The logic that exists for programs is based on mathematical models and systems. For example, the XYZ coordinate system powers creative freedom in programs like Blender, Krita, Scrivener, Godot, and many more. Algebra is a fundamental concept to building these tools. But math frequently works unnoticed, as the programs are written with creativity in mind and not math education. Think of it like a calculator that is making thousands of calculations a second. An arithmetic calculation gets fed into the next function, which triggers a new calculation and gets passed to the next function. Computers are optimized to ensure calculations do not need to be made more than once, or at least more than a few times. Once we calculate, we can store the pixel information and have other internal systems that provide the numbers again when needed. This is an oversimplification of computers, but the concept is there. This means that anything a computer does is likely tied to algebra, arithmetic, or counting in some way. To improve, get curious. Ask, how is this built? How is math involved in this process? Creators on YouTube are getting reasonably good at conveying abstract ideas in colorful ways. Math class may be rigorous and have tests, but that doesn't mean you need to seek out tests and quizzes in your own time. In my experience, even just consuming the content without understanding is enough to get my mind thinking about relevant topics. Don't shy away from things you don't understand. Despite the time pressure in classroom, outside of class, we have our entire lives to figure stuff out. Take it in your own time. In my opinion, learning 1 to 2 things about math a year is a reasonable goal for anyone that is not a mathematician. Hell, even a few things within a lifetime can feel validating and provide necessary encouragement. Keep doing arithmetic and try to identify patterns you haven't seen before. Learn to code and get curious about science. All STEM fields include algebra as a necessary background, so exploring them provides natural ways to see algebraic systems at work. Remember, even with what you currently know, it is far more advanced than most of civilization before us. Math is so integrated into our culture and stories that you are likely doing it without realizing. A good way to improve is to try to recognize the math you are doing on a regular basis. Intermediate level. This level is all about familiarizing oneself with the basics of algebra, the ability to work with unknowns and manipulate equations. Most will reach this level through a thorough general education. At this level, they would be familiar with the number line, Cartesian coordinate system, and graphs. They know exponents, roots, and complex numbers. They've spent time developing intuition for numbers, definitions, and polynomials that includes solving for x and y. This level is all about making preparations for leveraging ideas within algebra for science, technology, and engineering. To improve. It is hard to improve in this category without rigorous math classes. If you are interested in this subject, perhaps you are more of a math person than you previously considered. Advanced level. This level is a recognition that mathematics inspires understanding in science, technology, and engineering. Algebra is a critical element of each one of these topics and includes significant rigor. Algebra combined with calculus and statistics, offers significant insights to promote advancements. Each one requires rigorous definitions and understanding. If you find any of these topics interesting, I highly recommend Mathematics Up to Calculus. If you have an opportunity to take analysis or abstract algebra courses, I think it would be highly worth your time. Mathematician level. Abstract algebra has many subtopics and is where a lot of mathematicians choose specialty. Think of the subject as more of a gateway than a destination. Algebra is a vast topic and is not limited to just numbers. Geometry, language, video games, music, and more await any brave enough to venture through the gate.